Is mobile apps like iPhone and whatnot. We've heard that we want to start out with what the hell is .NET. We've heard interest in IoT, robots, and machine learning.
Unity.
Unity, we've got a Unity person here too, so we can make a game. Do we think that just talking about like C# and the ecosystem, and then we had a gentleman who was asking about, where'd my Java guy go?
About jobs.
No, the intro to Java.
Oh, intro to Java.
I guess he took off. He'll be back. So we want to talk about, like, there's a lot of different languages out there and you got to know which one to pick. So let's talk about C# to start with.
Yep.
All right.
So let me know.
So let's do this.
Yeah. Okay.
See which one of these slides is. I'm not a big slides person, but it's good for setting context.
Yes.
Oh yeah, that's a great point. So
Yeah.
thank you for saying that. So in fact, we're going to give you everything. Why don't you take a photograph of this screen? This here, AKA, also known as .ms/college tour, is going to actually point you to our GitHub. We're going to keep that updated, and that GitHub will include links to everything. So anything we talked about, we will put at /college tour, and we'll update it. So the slides will be there. We'll try to put demos and links there. We could even update it with some of the things we just talked about, like LinkedIn and Pluralsight.
Yeah, I'm taking notes as well.
Visual Studio is free. That's actually not my favorite URL. I just prefer visualstudio.com/free.
Okay.
And if you Google for Azure for Students, now here's a good thing and a bad thing. If you have a .edu account, you can get free Azure time. And since you don't here, we brought codes. So before you leave, make sure that you get a code and we'll give you a free year of Azure
With $100 credit.
with $100 credit. Cool?
So there are some services on Azure that are just always
yeah,
free,
always
and so
free.
that's that free year. And then the $100 credit is for the things that aren't free. After that year, you can put in a credit card number, and then you can still just use the free stuff, so you never have to charge your credit card. It's just, especially when we're learners and we don't even know what we're going to use it for, it's really intimidating to have to put in a credit card before you even know what the heck it is. So that's why we created Azure for Students. So that way it's just like,
Yeah.
you just put in your email address, and at the end of the year, if you don't want it, it's gone and there's no credit card anywhere.
And at some point, we might also want to talk about like WSL and stuff. I can show
Yeah.
you ways on Azure to get like a free Linux computer in the cloud, so you can go and play around and learn Linux, and you don't have to pay anything. So exploiting Microsoft for fun and profit is a good thing, and we don't want to give them any more money than we can, than we want to. All right, cool. All right, so Microsoft is historically bad at naming stuff, and .NET is a dumb name. It was invented around the year 2000, and it's kind of stupid because it's a top-level domain. Like, what if we called it .com? That would be really audacious. Like, who would do that? But we did that. I wasn't there. It would be like naming a programming language like .org, but we just decided to name it .NET. It's kind of a cool name because it was thinking about networks and stuff like that. Where things get confusing is that Java is both a language and a thing that runs stuff, a runtime or a platform. So there's the Java programming language, and there's the thing that runs Java, which is called the Java runtime. Python, Ruby, Node. Node's a little interesting because you've got the JavaScript language and Node, the thing that runs JavaScript. So they are a little bit similar. .NET is a family, or what they call a platform, of stuff of which C# is a language. So the C# language runs within .NET, just like the Java language runs in the Java runtime. There's lots of different languages in the .NET world. The three main ones are these. So C# is the main language. They would like to say it's first among equals. But if we look at these three languages, in fact, C# is so much more popular, we're talking like 100 times more popular than F#, which you probably never even heard of. And C# is 10 times more popular than Visual Basic. So it basically goes, if 1,000 people are using C#, 100 people are using Visual Basic, and 10 people are using F#. Now that doesn't mean that they're bad. It just means that there's like this many regular doctors and this many like heart doctors and this many brain surgeons. So F# is a bit of a brain surgeon type language. It's like for math people, it's super interesting. It's what's called a functional language, and you should check it out. But it's not a language that you're going to go and look on like LinkedIn or Indeed and find a job, because it's a little obscure, but people love it. Visual Basic was really, really, really popular back in the day, and I learned on Visual Basic. So if we look at this Visual Basic here, it reads very much like English, right? For each name in names, you see how these are different colors, or a list of string. That like seems clear. Like you could almost learn Visual Basic just by like reading it. Other than the word dim, which means dimension or make space for, most of that's pretty easy to read. The curly braces are weird, but for the most part, we all agree that that's pretty cool. Unfortunately, Visual Basic's not super popular. It was huge in the 90s, but more and more people were writing C and C++ and Java. And those are called curly brace languages. And they look like this. So here's the exact same code in C#. That's the exact same code, like line for line. So this is close. For each is now one word. For each name in name. That probably means variable, right? And then list, where it says string like this in brackets, that means of. So instead of writing of, they did it like this. There's actually as you get more into programming, you will learn about stupid jokes. And this is a stupid programmer joke. You get it now? That's how you remember if you have like a cup of tea or a list of strings, right? So now you're a total nerd now. We love this kind of stuff. There's all kinds of obscure programmer jokes, and people will make t-shirts of them. So once you remember these things, you start to realize that, I mean, Spanish, Portuguese, pretty close, right? There's a lot of shared vocabulary. See, that's all it is, see? Okay, see? So that's programming languages. Now here's the thing though. Let's use Portuguese versus Spanish as an example. Why don't the people who speak Portuguese just give up? They're not going to win. Pride. They like their language, right? French, people in Quebec, any Canadians here? Quebec people, why don't you give up? Just speak Parisian French. They're winning. People like their languages. Why don't we all just write C? Why don't we all just write Visual Basic? Because nobody wants to agree. Everyone likes their culture. And within software, there is culture. Some of the cultures are toxic, and you'll find mean people. There is certain programming languages that have a reputation as not being friendly, and other ones try to be friendly. It just depends. You're going to want to explore that as you move around. You might hear that, oh, the Ruby community is very friendly, or the Rust community is very friendly. You can go and explore that. Some communities have reputations either way. Culture is culture. But when we think about all of these different languages, you have to ask yourself, which one would I pick and why? And you have to balance the, I felt welcome, it made sense to me, it felt good in my mouth, right? Like this language felt better in my mouth. Like we've all done stuff where we learn a language in school and we're like, no, I tried taking French, didn't like it, took Spanish, I liked it, took Japanese, that felt better. As you explore languages, don't get caught up in someone else's religion. Because some people will be like, oh, you're learning C# over at Mesa? That language is trash. You need to learn, right? And then they'll try to convert you to their religion.
Hey Scott, what did you mean by you feel welcome?
If you feel welcome, like, let's say I teach you all .NET, and then you go out and you go onto a forum somewhere, and there's lots of different places. Could be Reddit, could be Twitter, could be Facebook, could be anywhere, could be a Slack. And you're like, what's this list of T? And someone is like, noobs, freaking casual, you know, like, and then you're like, whoa, I'm just like asking a question. I guess that's like that. Now you are no longer feeling like that's your language.
Yeah.
Does that make sense? Right? You're going to get slapped around in programming. Okay? Like I'm taking Taekwondo right now, and I'm learning about the culture of martial arts. I've got a tournament tomorrow, and some of the black belts are assholes. That, you know, I'm hoping one day to be an asshole, but I'm not. But some of them are super nice, and it's just like, wow, like you're like a 6-degree whatever, and you're like made of shoe leather, and you're all like, and you're being nice to me. That's what you want to feel like when you enter a culture. You want your mentor or your people that you work with to make you feel like there's no dumb questions. And here's the thing, not to get too deep, and you can tell me what you think, but like you will feel like you can ask for help, like it's a weakness to ask for help, or like maybe I should just know this. I'll just go and I'll stay up later and I'll work harder, and then maybe it will magically come to me. Because if you ask for help, maybe because you're a woman or because you're not white, that someone is going to look at you and say, oh, well, here we go, they're asking a question, they don't know what they're talking about, and it means something. You want a community where you can go and ask a question and not feel like they're going to judge you. Or they might think, oh, you're older, or whatever. Now, as an old dude who's been doing this for 30 years, I can ask dumb questions, and they won't flip the bit on me. You know what the bit is? You know, a bit is a 1 or a 0. Right? A bit is like, this guy. Boom, the bit is flipped. Like you ask a dumb question, I flip the bit, and now I'll see you again. And it's that guy again, he's asking those dumb questions. Nobody wants to feel like that. So you want a community that will not flip the bit on you. We try to make .NET that community. But if that happens to you, then find another community. You will find another job. If you don't like the language, if it doesn't feel intuitive, find one that makes you happy. Does that make sense? Any comments, questions, thoughts about that?
I think that's always my favorite question that I get asked is like, what's your favorite programming language? And I'm like, the one that'll solve the problem.
The one that gets me paid.
The one that gets me paid, yeah, whatever the problem is, whether the problem is a technical problem, or the problem is I need a job, or the problem is I need docs, or whatever it is.
Exactly.
Whatever will solve the problem.
The thing is that in technology, especially when people get older, myself included, we get excited about our religion, and we want you to convert. Have you heard the news? You heard the news about .NET? You don't want to get involved in any kind of that stuff, because anything can be written in any language. You can get a great job and be successful in Java, or Python, or Ruby, or whatever. I'm excited about this religion. If you like it, cool. If not, that's cool too. But don't get wrapped up in any kind of zealotry. Okay? But here's the part that's interesting. Remember when we compared these things a second ago? It's interesting to have the argument, is this better than that? Is a hybrid car better than an electric car, better than a gas car? They're all just cars. You can have arguments about the merits, the good or bad, of these different techniques, but it's still got 4 wheels and it still gets you where you're going. Which brings me to another really interesting point. When I started learning to drive, I was told I had to drive a stick shift. They said, you need to drive a stick, because one day someone is going to break their leg and you have to drive them to the hospital, and if they don't, oh, God, he's dying. Oh, this is a stick. You're dead. Right? Sorry, I never learned to double clutch, so I can't take you to the hospital. But now people will be like, why didn't you just Uber? Right? So my dad was like, well, I'm not going to teach you how to drive until you can change a tire, or until you know how to change the oil. So should I teach you how to wire up and build your own computer before I teach you how to make a for loop? It depends. It depends on if it feeds your spirit, if it makes you happy. Because you need to think about, from your perspective, as you drive your car or take your Uber, is it important that you know what's going on under the hood? It's not important from a job perspective. It's important to know the car has wheels and, generally kind of how cars operate. But then the question is, can you change a tire is very different from, can you rebuild the engine by disassembling and reassembling it? Does that make sense? So think about where you want to be. Think about what makes you happy. If you like building a computer, or maybe you just want to take it apart and build it and put it back together just once, just to say you did it. I have changed my oil one time, and now I pay a guy. You know what I mean? Like that's my thing. I know how to do it if I needed to. So I can teach you cool internal things, and you're like, oh, that's amazing, right? That's amazing. Now I know how the toaster works. He took it apart, and we see the science of toast. And other people might just say, well, I'm just going to buy another toaster. I don't really care why it's broken or not. Don't let someone think that you're not a good programmer because you chose not to pop the hood. Cool? All right. So those are some languages, and they live within this thing called .NET. What gets confusing sometimes with a computer is that you can't really point to, like, where's the thing that runs the thing? Because you like get lost just in the machine. You know what I mean? If I go out to the command line, and you can do this if you want to, you can hit the Windows key. By the way, all these machines are on and have everything installed, so you're welcome to follow along, and you also don't have to if it doesn't make you happy. I just hit the Windows key and R, I typed in CMD, and I'm at the command line. So Windows R for run, CMD, and it'll come up. Yours won't look like mine because I made the font big. Okay? And if I type, oh, it's got it there, CLS. If I type .NET -- version, it's going to tell me that I have a version of .NET. And if I type the word where in .NET, it'll tell me where it is physically. Like literally it's saying, hey, where is this? It's on my C drive, in a folder called Program Files, under a folder called .NET, and there's the thing. This is the .NET runtime. This is the thing that runs .NET stuff. It's confusing and we won't get too far into it, but there's lots of different runtimes. Just like with Java, you can run Java in multiple ways, right? Toyota, Honda, Hyundai, they all kind of look the same. It's all basically the same car. Same thing happens with Java. There's the Open JDK and the Zeus JDK and the this and the that. There's multiple ways to run .NET, but for the most part, this is called .NET Core. You have it on your machines. It's free. You can download it. It's about 100 megs. It's not a big deal. So I said .NET -- version. It told me the version is 2.1, and it's located in that location. Now I can go to my desktop. I can say CD desktop, and again, I'm showing you stuff at the command line. You don't need to do this. We'll go into Visual Studio in a minute. And I'm just going to make a folder here. So all I've done is I've CD'd or changed directory into desktop, and then made a folder called Mesa, and now I'm in Mesa. Again, if I'm telling you stuff that's too high level or too low level, you tell me. Because some people don't think like this. You'll notice here, whoops, I could have done it graphically as well. Same thing. You notice that that is empty. And I'm going to go like this. I'm going to pick up this window, and I'm going to shove it up against the right side. You see how it just went whoosh? Whoop, whoop. Okay? And I'm going to say .NET New. And what it's going to do is it's going to give me a list of all the stuff. The fonts are big, so bear with me. This is all the stuff that I could make with .NET. Make a new console app, make a new web page, make a new this and a new that. This is the stick shift version of going into Visual Studio and saying File, New, Project. So you have Visual Studio on these machines. You can go and just hit the Start menu and type the word Visual and run Visual Studio 2019. And it'll pop up a thing like this. And in here, it gives you choices. You can make a new project. You can open a project. I'll just click on Create a New Project. And over on the side here, look at this list of stuff. These are all things that I could do. I could make a console or a text app. The console is that black text that we went down to. That list right there of stuff I can make is the same as this list here. Let me make the fonts a little smaller for just a moment. .NET, oops. .NET new. I don't know how to type and people are looking at me. There we go. See all these things here? That's a bunch of stuff you can make. Basically the same as that list. This is a graphical interface and this is text. Now, remember how I have an empty folder on the right here. You could say .NET new console. Or I could go and do that inside of Visual Studio and say File, New, Console. And I'm going to hit Enter. And see, stuff just appeared on the right. I could have totally just opened up Notepad and wrote that myself. This just jump-started it. This is really important because when you're starting out in computers, there's this sense of there's a lot of magic. I did a thing, I clicked a button, some shit happened, and now there's stuff here and I don't know what happened. This is a template that was created. And you can see over here, it literally just said the template was created. Somebody set aside what a basic app is and wrote that for us. You could have done it yourself. You could have built a car from scratch from a kit. But you could also get some pre-made parts and get a jump start. This is a jump start. There are no black boxes on a computer. This is so important. We are not interested at Microsoft or any other company if you know about all the little trivia. If you go to an interview and they want to know about trivia, then you're not allowed to Google for anything, you can't ask any questions, then you don't want to work there. We want to know if you can think, if you have a general sense of how things fit together, and we want to understand that you want to dig deeper. We are not interested in all the little details. This is not a black box, meaning that I can go and find out where that template is and look at it and make my own. You can explore all this stuff. Nothing is hidden from you. This is so important to get. Please, sir.
Just a call ahead, when we do the life after school skills, we can talk a little bit about interview questions and what happens when you get those trivia ones and what a good company or a good interviewer is looking for.
Definitely.
We'll call ahead to that.
Appreciate that. Now, I'm going to go into Visual Studio and I'm going to say open a project because I made it at the command line. I went .NET new console. But I'm going to go and I'm going to pick this file up because I want to show you. There it is. I'm going to open this up. And I'm using, by the way, I'm using Control Scroll to make my fonts bigger. So, who here has never ever done anything in Visual Studio? They've never even opened Visual Studio. Okay, cool. What have you used? Have you used another app for programming, or have you never done any programming?
Well, we use BlueJ for
BlueJ. Okay, for Java?
Python. We
For
use
Python. Okay. Okay, cool. Anybody else?
Arduino, Unity.
Arduino, IDE, Unity.
Yeah.
There's lots of different IDEs, integrated development environment. Here's the thing that people don't get sometimes. I'm at the command line here, right? I'm at the lowest level. And there's my program.cs. I'm sitting in the C drive in the Mesa folder here, and I'm going to go and type Notepad P. I'm getting ready to type program. Tab. I'm lazy. Enter. And I've opened this in Notepad. Like this, I'm telling you obvious things, and if I'm wasting your time, I can go get a lot more complicated real fast. But I want you to get to a couple of the fundamental things here. Is that an okay place to program? I mean, it would work. There's nothing wrong with that. That's how we did it. The first 20 years of my life, I was programming in a text editor. Here's the deal, though. If you give a newbie that, and you go, welcome to programming, woohoo! It's like, oh shit. Or you give them this, welcome to programming. It's like, ah. So you're basically screwed either way. Right? That's a lot, right? There's a lot. You start opening toolbars and boxes and stuff and menus, it gets a little intense quickly. Especially when the menus start flying out into other menus and flying out from there. So what's the best way to do it? How do you introduce someone to this? What I need you to get is that text is text. 99% of what you're going to be doing is just text. If we go out to the command line here and I say the word type, program, that's the same thing. Text is text is text. Now you might go to a company and they say, oh, well, we do everything in Unity or we do everything in BlueJet. It doesn't matter. That's just the thing that they've chosen. It's just literally like the steering wheel cover. Car is the same. Sometimes you might be the only person at the company that has a Mac or the only person that wants to use this editor. And text editors are a religion too. There's some old people who use VI and Vim. You ever meet them? Ooh, that's intense. Emacs, I mean, that's a whole thing, right? And then you don't pry it from my cold dead hands, like this is my text editor.
Use a mouse.
Yes, yeah, exactly. And this is the thing, right? You use a mouse?
Oh my gosh, you're not a real coder.
You're not a real programmer. I saw you move the mouse once, right? We gotta have the hotkeys, right? People are obsessive. People build their own keyboards. We don't talk about culture. There's a dude I know who carries around different alternative keyboards, and he's got like a split keyboard with like a string between them, and he keyboards like this, and there's like wire. Like people get intense about this stuff.
Whereas I asked Microsoft to buy me a Mac.
Yeah, and that's cool, right? And so when we talk about like inclusive culture isn't just gender and color and age. It's also like using the thing that makes you happy. So we let people at Microsoft basically use whatever they want to use. And we laugh and we joke about the Vim and the Emacs people, but if that makes them happy and it lets them do it, that's cool.
And I still go down to Vim every once in a while. If I'm just trying out a simple little, like, I can't remember how to do math and I want to do something a little complicated, I might just open up Vim for a sec, because that's how I learned.
And see, then I just have to reboot the computer because I don't know how to get up. All right. So, at the command line, where I've got my little program here, and let's remind ourselves what our program looks like. It's hello world. I can make a change. And then I'm going to go back. And you see how quickly I'm moving here? I forget about stuff like that because it's so intuitive. Are you noticing what's going on there? What am I doing? Alt tab. Be good at that. Be good at that. Because, like, also be good at something like, if I click, that moves the cursor, right? If I double click, highlights the word. And if in some editors, if you triple click, it gets the line. And if you quadruple click, it gets a paragraph. Wow. Knowing little stuff like that and being able to go, like, double click, Control C, Control V, do know how to do that. That's not programming, that's text editing or text manipulation. Because otherwise, here, let me make my mouse bigger. Otherwise, mouse pointers, mouse options, pointers, extra large. That's not that big. That's big enough. All right. Otherwise, you're going to be this person. And the thing is, it's right there. Like they're teaching you the hotkeys. Now here's the part where it's confusing. There's like 20 just right there. So then you're like, oh my god, I have to remember all these hotkeys? You don't. Just get like 10. Moving around, selecting text, workflow,
your
whatever
app,
works for you.
You know, your editor of choice, and then get good at that.
Yes, pick one and get good at it.
I actually have a good video about that
Oh, yeah?
our GitHub colleague made. I'll put it on the GitHub repo.
Okay, so I'm at the command line here, and I'm going to type .NET space run. Enter. 1 1000, 2 1000, 3 1000, 4 1000. Hello world. Okay, it works. That's cool. It took 4 seconds though. That's 4 seconds. That's a long time for hello world. What's wrong? Anybody know what was happening in those 4 seconds? Why did it take so long?
We're trying to find it.
Trying to find it? That's a good question. That's a good answer. Trying to find it, maybe?
It was compiling.
Compiling it, making it, creating it. It didn't exist before. Let's do this again. Watch this. I'm going to go and put this on the left. Remember, again, I'm going to pick this up and I'm going to snap it. And then I'm going to snap that. You can also do it with the keyboard. Windows key, left arrow. Right arrow. Up arrow. Good, huh? Get good. I'm going to go and delete these two folders. And I'm going to type .NET Run again on the left, watch the right. So it made the program. We can go into the bin folder, bin for binary. And we can see it made this thing, DLL, mesa.dll, dynamic link library. That's the program. Sir?
I was able to write on it like, so fast.
How was I able to what?
Write on the.
Oh, how am I doing this?
Yeah.
Magic. I'm using a program called Zoom It,
Oh, that makes sense.
and it's free. And it lets you do this kind of thing. Which is pretty cool. What it's actually doing is I'm hitting a hotkey, it's taking a screenshot, zooming in on the screenshot, then I scribble on the screenshot, then I hit escape.
Yep, let's go back.
Yeah, cool. So, let me go down into that folder. All I'm doing, this looks really fast. Let me actually slow down. I'm typing fast, but it's really because I don't know how to type. Okay, there's a folder called bin. Underneath that, there's one called debug, and underneath that, there's one called netcore. So it's 3 levels down. So what I'm doing is I'm typing cdb tab, 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 enter. Make sense? Okay. Oops. There we go. There's the thing I made. I could say .NET Mesa. That's fast. Why did one take 4 seconds and one took no seconds?
You specify it?
I was being very specific. It was already done. One .NET Run compiled it. .NET whatever Mesa just made it work. Is there a way to turn this slide off so we can see this less washed out? It's probably going to make us all plunge into darkness.
So I'm watching you do it in all of these things. Like what, I mean, I know you talked about like people having their preferred way of doing it. Is there like an actual benefit to like doing it like on the command line versus like in Visual Studio versus like
Fantastic question. Fantastic question. So you follow what she said? Like, what is the benefit of me doing it like this? Am I showing you my preferred way and thereby messing you up? That's the implied question. That's a great question. And the thing is, I'm doing basically the most generic thing. I have no opinion here. I'm not using Vim or VI, I'm using Notepad. And I'm at the command line. And the only thing here that's even remotely opinionated is I made the text green. I'm doing that because I wanted to show you what Visual Studio is doing. Because you could totally and should probably for most of your career just spend time in Visual Studio until it breaks. And then you're like, I don't know what to do. So then you would go and look in the folder. Like for example, let's do that. Let's go over to Visual Studio. I'm in Visual Studio. The same exact file is still there. There's the spaces that I added. I can hit start without debugging. So I go to the debug menu, and I say start without debugging. Now, because I'm learning, I see this, and I go, oh, I'm going to do that multiple times. So I'm going to think about that. Control F5, Control F5. So I'm going to hit Control F5 instead of clicking the menu. And then it popped up the thing. That's cool until something broke. And then I would need to basically go out to the command line, maybe delete some temporary files or clean up. Or maybe if I moved something or someone gave me some software and brought it onto my machine and then it broke. Visual Studio can only tell you so much. Right? At some point, something in your car will fail and you're going to need to pop the hood. So I think it's nice to know that even though I said debug, start without debugging, Visual Studio just called .NET Run. So if you saw in the corner here, it's super small. Build started. And look, there's that folder again. So Visual Studio is telling you the things that I'm showing you, but it's doing it in a very low-key way. There are a lot of people out there who might have 10 or 20 years in the business who have never left Visual Studio. They just live here. And that's fine. But then, if it breaks, then you have to go and ask your coworker. So I take some joy in the underneath. Yes, sir?
Yeah, another scenario might be that you're remotely logging into a system and you're working with stuff, and it's a headless system. You don't have visualization capabilities, and yet you can get in there and get stuff done.
All right, so he's got a good point. So not everyone has a graphical interface. Not everyone has a friendly IDE. Visual Studio is different than BlueJ, which is different than Eclipse, which is different than whatever. And each of these text editors or environments are differently capable. So if you're remoting into a machine, let's pretend that we're doing that. And I'm out here. And I'm going to go and say Vim. So now I'm doing text in an editor, in the console. It's got like color. It's called syntax highlighting, where it's looking at certain keywords, and you get to pick the color. It doesn't always look green and weird. But you can tell that it knows string is important, and it knows void is important. And it did that so that you would notice if you spelled something wrong. See? So there are jobs and environments where they might say Emacs a plus. They're saying we would love it if you fit into our culture. And you can decide whether that's important or not. Knowing how to do the basics, just the basics, at the text mode is a way of you saying, oh yes, I've used Visual Studio, but I've also built systems in Notepad or Emacs. Great question.
And part of why we show it here is because if you've seen it once, then next time when you want to go explore it on your own, you're like, wait, that Scott guy did something and it looked kind of like this, so I must be somewhere in the right place. Right?
Exactly.
And that's
exactly.
totally okay. And so that's why we want to show it to you at least once.
Here's the second thing. Let's look at the right here. You have, if anyone's following along, in the Solution Explorer. So you're in Visual Studio, and on the right-hand side, there's a thing that shows your program. It says Program. But then it says Dependencies. And I'm like, dependencies? Let's go back to Explorer, Alt-Tab. These things are not lining up. Let me go and view it as a list. I'll put them next to each other. Let's zoom in. That's what Visual Studio is showing us. That's what reality is. Visual Studio actively lies to you. Is that a good thing or a bad thing? It's a good thing. Do you know that your car actively lies to you if you're driving an automatic or a continuous variable transmission, right? Your car lied to you when power steering was invented because there was a time when there was a direct line between the wheel here and the wheels there, and now it's just a lie. It just feels like they're connected. This is true. But we accept those lies because they make our lives easier. These things here are what are called build artifacts. They're stuff that happens. It's cruft, it's schmutz that happens when you go and build your application. But seeing it can freak people out. So Visual Studio hides it from you. This is what's called the physical representation of your computer. Those are actual physical files we can look at. There's 4 things here, 2 directories and a file, and I can go here and I can say dir, and there they are. That's the same 4 files, no lies. But we go back to Visual Studio, and let's open this up. I'm going to open up everything. That got scary real fast. I'm going to close that because that's freaking me out. Let's just do it this much. That is not physical, but that's what's called logical. Right? It's a representation of my program, but it's not reality. The only thing that's real here, the only thing that's real is that file. Everything else is a lie. But that's good because it's a lie that I need to do my job. It's a nice, helpful thing. That's the difference between a text editor and an integrated development environment, or IDE. Some people don't like that. Some people think that your Jedi's got to make his own lightsaber. And some people think that this makes you weak. When I was learning to program, we were just getting from basically Notepad, just black text, white background, to getting syntax highlighting or coloring. And then when you would type your variables and it auto-completes things for you, and like, oh, I know what this is. Or you type like foo dot and then it pops down all the things. We would literally have teachers say that rots your mind. Like you're weak if you get the computer to help you. Whether or not that's a correct thing or not is up to you to decide. But the reality is those things will be available. But if you showed up to work and they didn't have this, like you made the comment, Dwayne, or if they turned it off or it was broken, are you crippled at that point? Are you like, I pushed stop and nothing happened? You need to be able to roll with that. So these are things you want to think about. Don't have them, they're just speed bumps. They're not reasons to stop programming or not. It's just knowing what's going on. So you see how it says program? That is my class and my function. Let's do this. Over here, I'll just make a public void foo and hit save, and look what happened over here. So immediately, as a programmer, I'm like, that's useful. Like I can see where my program could get really long, and now I've got this nice cool list of functions, and that's cool. I can even figure out by looking at it what it's trying to say. Like there's like a little lock here, so this one's different than that. Right? Like things are starting to get interesting. Maybe this could be private. And would it change the lock? See? Like the lock just showed up. So that's useful information it's presenting to me. If I added a variable, would it show up in there? No? Yes. And it's got a little icon of its own. So that's a cool thing. When we were programming before, we had to hold a lot of this structure in our brains. Because if it's not visible, it's in another text file. And a lot of times people get overwhelmed trying to hold this stuff in their brains. So IDEs like this try to present it in different ways. Unity, what we'll see a little bit later, has these trees that explain the scene in the video game that you're making. There's lots of visualizing tools. If you do something like Google Docs, there's usually like that thumbnail that shows all of your pages, or if you have like a really complicated paper and it's freaking you out, you zoom way out so you can kind of get a sense of what the next 20 pages look like. The same thing applies in the programming world. You see that green line over here? And these squigglies? Look at this. Right, this is just like in Word, right? We're getting spell check, or we're getting grammar check. You don't get any of that stuff if you're using a text editor. But I turn off spell check when my 11-year-old is doing his reports, because it rots the mind. So it's useful to see, occasionally, can you write a program without the help? Can you write it without the squigglies? I wouldn't recommend you do it now, but you gotta know why those squigglies are there. You don't get squigglies in Notepad. So for example, if we go back here and we say console, see how it immediately starts giving me what's called IntelliSense. So remember when I showed you before when I was like change directory space, I typed one letter and I hit tab. Because it's like, I don't need you to write it all, I know what you mean. C-O-N tab. That's just convenient, that's just helpful. Dot. So look at that. So that's giving, oops. I'm trying to zoom, you see what's going on? I'm trying to zoom in, and I gotta catch it fast before it fades away. There we go. So here, it's got a drop down of the stuff that I would do. Some IDEs just do it in alphabetical order. They'll be like A through whatever, and they just expect you to type it. Visual Studio, see how they have 3 stars at the top? Those are the 3 most likely things that you'd want to do. Because there's like 11 things you could do with a console. But the 3 most common are read a line, write a line, and read a key. So it's just sticking them at the top. Now you know that, and 3 years from now, you will remember that because it'll come up at work. Does that make sense? A big part of programming is remembering a small thing that then allows you to go and search for or check the documentation. People who are gatekeeping, who want to prevent you from being successful, will tell you that it's remembering all the little details in totality. It's not. It's just like, oh, there was a thing. What does the star mean? Google IntelliSense star. Oh, it's that thing. So I have a 30 years of little random shit that I can use to Google for. I do not have an encyclopedic knowledge of software. I keep just the little thing that will go, oh yeah, there's that thing.
Is that new, Scott, for that favor?
The stars are new. So that's actually using machine learning and artificial intelligence. And we've gone and taken all of the source code on GitHub, analyzed it, and determined that those are the 3 functions that people will use. Think about that. Imagine if all the world's source code was a database you could query. It is. So we took all the source code on GitHub, queried it, and for every single class that you would use inside of Visual Studio and .NET, we've put the top ones at the top. Isn't that cool?
Yeah.
Yeah. That's the next revolution, is the program helping you program because, oh, you probably meant this. But just like self-driving cars, it's not real. You need to be responsible for your vehicle. Everyone's like looking at videos on Reddit of Teslas parking themselves and like, oh man, I don't have to learn to drive. This is great. I'm going to Uber. The Tesla will come to me and drive me away. But if you kill somebody, it's on you. You were in the car. Same thing applies. These are all fun tools, but if you don't know how they work, if you don't at least have a sense. And again, I'm not giving you homework. I'm not saying go learn for an hour. That was all you needed to know. But you have to register it, file it away, so that when it comes up later, you can look it up.
Yeah, so I did a little bit of research on like user experience and user design. And the biggest thing when it comes to either self-driving cars or starred things in Visual Studio is technology can help focus the computer on what it does best, like searching an entire database of all of the code that exists in the entire world and making a suggestion, to allow you to focus on what you do best, right? Which is the actual thought behind the code. And that's the same with self-driving cars, right? The self-driving car can focus on what it does best, checking blind spots, while you focus on what you do best, knowing where you want to go, right? Or making an executive ethical decision of whether you're going to hit the biker or the walker, right? But that means that you, the human, are still a part of the equation always. And if you're ever designing an application or using one that claims to allow you to become like out of the equation, that's not true.
Just like autopilot
Yeah,
isn't the thing.
yeah,
You still have to point it at where you're going.
right.
You know the program you're trying to write. It might help you write a for loop, but that's about it.
And have you all heard of pair programming?
Oh, yeah.
Yeah, so you have one person who's at the keyboard and mouse,
And one person who's pacing around going like this.
yeah, who's just kind of watching a screen. And we call them the driver and the navigator. The driver is typing, right? And knows where they want to go, but is focused on typing, like the driver in a car is. They're focused on pushing on the gas and steering the steering wheel. The navigator is like, whoa, 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 you accidentally used that variable name. I think you meant the other
Right, you
one.
took a wrong turn, turn around.
Yeah, right? And that's the same type of thing. So in humans, we can have a pair programming driver, navigator. Your tools are also part of that pair programming, kind of.
And this is a really important thing. You know that feeling when the navigator is trying to tell you how to drive? That can happen if you do pair programming.
Yeah.
So if you have differently skilled people, and I really recommend that you all try pair programming, stick to your role. Even if you're the advanced one and you're on the keyboard, your job is to type. Your job is to type, to get it right, get the syntax right. Let the navigator also be wrong, just because you might be at a different skill level than they are. And then switch roles and try that out.
And sometimes you'll notice things, and it's the same with tools, right? The tool might be trying to tell you to do something. You're like, I know that that's wrong. But if the tool is telling you, maybe take a pause for just a second, say like, but wait, why is the tool telling me that? Maybe there is something I'm not realizing. Sometimes you're still right.
This is so
But-
important. I love that.
Sometimes you're not right. Sometimes you forgot, oh, I was supposed to do some garbage collecting, or I was supposed to change that variable name. Oops, I did do a typo, or I did a typo when I made the variable name, and I've been using it with the right spelling the whole time, but I didn't realize that that typo existed, right? So just take a pause, when the navigator, whether it's a human or a tool, whether
Right.
you're driving or
The
coding.
GPS is
says
not always
something.
right?
Exactly.
I've had GPSs take me right into like a lake. There's no one to
That
take me
Office
across the
episode?
lake. You know?
Have you ever seen that Office
Exactly. Like, there's no
episode?
ferry there, no one's taking me across the lake.
It's telling me to go here.
When you're getting started, and I know some people here are in different levels in their career, but you got to understand that you by default will assume the computer's right and you screwed up. Everything you do, you go, oh, shit, I screwed up. Maybe you didn't. The computer is not smarter than you.
And even if you did, that's an opportunity to learn how.
Exactly. And the computer will tell you that the error is on this line and it's 5 lines away. Right? We always talk about the $1 million semicolon. Where I was looking over here and it was a semicolon way over there and I had 6 engineers staring at it and we spent it for weeks and it was over there. That will happen. And you've got to understand that the digerati, the programmers of the last 30 years, have made y'all, normal people, you're not normal anymore because you're programmers, but we've made normal people feel like it was their fault. How many times have your parents or grandma call and say, oh, I did something to the computer, I'm sorry, I broke it. And they just went to a web page they shouldn't have gone to, or a pop-up came up, and the computer made them feel like it was their fault. We have designed systems that make them feel bad, like I broke it. But when I gave my 90-year-old great uncle an iPad, the first thing I said is, you can't break it, and if you do, I will fix it. And he is fearless. Imagine telling someone that you can't break it, go nuts.
It's literally why I switched into computer science, because I was a pre-med major, for those of you who weren't here at the beginning, and you can kill people there.
I've heard that.
I can't kill people here. I mean, depending on what software I'm building, but like, you know, in
Yeah,
my
if you're
normal
writing,
day-to-day, I just restart it.
Yeah.
It's great, I can try anything.
You can just back up your stuff,
Yep.
email your homework to yourself, use
Yep.
source control, whatever it takes. But you can't hurt yourself and you can't hurt this. Okay, so a couple other things I want to talk about, and then we'll probably take like a little short break, and then we'll figure out what we're going to do next.
Yep.
How many people did, and we weren't sure whether we would use the computers or not. It sounds like a lot of people are not trying to follow along, right? And we can try later if you want. How do you want to do this? We could take 5 or 10 minutes, and it'd be cool if everybody launched Visual Studio, said file new project, made a console app, added some code, changed some code, and then maybe did a little something. Is that okay with us? And then we'll do a break? Okay.
And food will be here pretty much when that whole project ends. Pretty much, yes. We ordered from San Diego Burritos, or California Burritos.
Some kind of burrito.
The one that's local.
Okay, so I'm going to launch Visual Studio,
It wasn't.
and I'm going to click Create a New Project. And when that pops up, the one I'm going to pick is the console app. Yes, sir.
So, whenever you program and you have something that's under arguments, why does it always have the thing or?
Yeah, let's talk about that. This is a great question.
No.
Let's get to that point in about 2 minutes, and we'll answer that question.
There's another open computer right here if anyone wants to join.
So he had a great question. He was talking about, when you see the R's, what we're going to do is we'll make our app, and then let's actually disassemble or talk about the components of a Hello World application. Hello World is the classic thing. If you ever get a new programming language, the first thing you do is you make it say Hello World.
And that's where there's like stickers and buttons and shirts with Hello World on it.
Yeah. So I'm going to go and click on Console App, and it's going to ask me for the name of my project, and it's going to tell me where it wants to put it. And there's a little checkbox at the bottom here that says place solution and project in the same directory. You don't have to check that, but a solution is a collection of projects. Right now, you'll have one project, and it is a member of a solution. But in the future, you might have an app. It's got 3 or 4 projects. Like if you made a tic-tac-toe app, you might have the game engine, and the iPhone version, and the Android version, and the Windows version, and the Xbox version. So you'd have a solution with N number of projects. Make sense? So let's just go and make our app. Hey folks. Hit create. And then it's going to chew for a second, and then it's going to fire up Visual Studio. And if you hit, again, Control Scroll, you can change your fonts here. And your screen will probably look something like this, where you have what's called the Solution Explorer on the side. And if you want to make any changes to Visual Studio, there's a thing at the top that says Search Visual Studio. There are so many menus and options in this world, it can be overwhelming. And you might feel that you need to memorize menus. That's a bad idea. Just search for the thing. So for example, this theme, I'm not really feeling. So I'm going to type in the word theme in the search box at the top. And I can go and change the theme, and this is actually going to go into a menu item, and I could then change it to like be blue. Or light. We're in the dark mode. There's, right. I think that's a little easier to read. You can change your fonts, you can change your style, you can make things bigger or smaller, it's totally up to you. There is no requirement for this looking a certain way. Okay? I think that's easier to read for me. So I just did that. I could have gone tools, options, environment, theme, blah, blah, blah. Or I could just do this. Now look, notice, what is this trying to teach me? Don't ignore that stuff. Control X, Control C, Control V, cut, copy, paste.
This is also just a really important note. Documentation, books, they go out of date quickly, especially with the interface. Search bars are your friend, right? So if you see a documentation or a book and you're like, I don't see that on my screen, but it has like a title of something, just search it. Whether you're in Visual Studio, whether you're in Azure, just search it in the search bar and it'll likely come up.
Okay? So, I don't need to remember where stuff is. I can search for it. That's super. I just changed the color and the theme. Over on the right-hand side, I can explore that by opening this. That's called a tree view. Again, there's a theme. Look at this. Search Solution Explorer. Control, semicolon. I can even search for the names of functions. Or if I lose a variable, I can search for it. So I know copy-paste. Practice your text editing. It's obnoxious if you are going to be in the industry for 5 or 10 years and you're still selecting text with a mouse. A couple of basic things you can learn. Really, really encourage you to do that. The faster typer you are, the faster you can get the stuff from your brain out to here, the better you're going to be. Because this is your CPU, and this is your I/O, your input-output. And everybody knows that a fast computer with a slow disk drive is just waiting around for the disk drive. So get that stuff out of your brain as fast as you possibly can, into your hands. So don't be this person again. We don't like that person.
Universally.
University, learn how to do it. So I'm using the cursor, I'm moving around. I can go and hold down the control key. I'm holding down control, and I can move function by function. I can select entire lines. Duplicate them. I can even do badass things like this.
Wait, you duplicated by pressing Control C?
Right? Like, there's a lot of cool stuff you can do. So what was your question, sir?
Were you duplicated by pressing Control C and Control V?
I went, so what I did, and actually let me show you something. This might be fun. I haven't done this before. There's an app, since we're installing random apps, that I'm going to install real quick, called Karnak.
By the way, I'm trying to add as we find cool things to the repo, just like in a section called cool things at the bottom. So,
All right, check this out, kids. See that up there?
Oh yeah, I thought you
You
would.
like that? Okay. Yeah, I like that. All right. So I'm over here, and my cursor's flashing on console. If I hit end, I go to the end of the line. If I hit home, I go to the beginning of the line. If I hit home again, I went all the way to the other side. If I hit shift, down arrow. It didn't just move down, shift brought the selection along with me. So I can go down, down, down. Right? I can hit Control A to get everything. A for all. Keep in mind, I don't know a lot of hotkeys. I just know the ones that matter. Control A, all, that's cool. Shift down. I'm gonna wait for those to fade away. Control C. Then Control V, Control V, Control V, Control V. Okay? So get to a state like that. Now, the Alt key is like Shift, right? Shift is for like uppercase. Alt is for like alternative. I'm going to hold down Alt. I'm holding down the Alt key with my left hand and I'm mousing with my right. And I can select a square. You're used to selecting lines, but you're not used to doing that. So I've selected a square. Hold down Alt and select your square. And then whatever you type gets repeated. You can see where that would be useful if you had like a text file with a bunch of numbers and you were trying to replace them all or whatever. Like this text manipulation makes you a better person. No joke. Follow? Anybody having trouble? Now, this is just kind of standard manipulation techniques. If you're using Vim or Emacs, there's a different flavor. Again, Spanish, French, Portuguese, just different languages. Pick the one that makes you happy. There are a lot of really good tutorials out there that will teach you. And these hotkeys, I call them hotkeys. Other people will call them key bindings. So if you hear that word key binding, for example, I met a developer over at UCSD who was a professor, and they said, you know, I like all the cool stuff Visual Studio does, all the squigglies, it's cool, but I also love Vim, so I'm going to keep using Vim. And they were like, I'm sad because I love Vim, but I also like this. And I said, well, you know, you can change your key bindings and install VS Vim. That gave them the hotkeys that they love, the key bindings, with the bling of Visual Studio. So you can do that. You can make your editor the way that you want it. Like if you're a person that likes a funky keyboard, then bring your funky keyboard to work. If you like your key bindings a certain way, once you get this the way you like it, hotkeys, everything is changeable. Check it. You can get it just the way you want. Export the settings, stick it in your Dropbox or your Google Drive. You roll into another machine, you're like, I gotta set this all up again. I like it a certain way. You just say import settings, and all of your settings are that way. If you sign into Visual Studio, if you sign in with your Microsoft account, your Xbox account, your settings will roam. They'll follow you. So when you sign in up here, it'll bring your settings with you, which is really cool. So you don't have to learn stuff if you don't want to. You can go and change them. So look at this. Apply the keyboard mapping scheme for the thing that makes you happy. For whatever you're used to, if you don't like Control C, Control V, you can change it. We don't care. You just need to be able to do it fast. Okay? Change this. And then hit Control F5. And you should be about there. Visual Studio called .NET Run. It made that DLL, that program, and it ran it. This text might be a little bit small. You can click in the upper left-hand corner of the box and hit Properties and make it bigger. And you'll see some different stuff, a little bit different than when I ran it from the command line. Remember when I ran it, it said hello world, and then it didn't say anything else. Visual Studio's adding extra stuff on that extra line. What does it say? .NET exited with code 0, and it has a number. Are your numbers the same as my numbers? Let's see. You all have code 0? You all have a 5-digit process number?
Yeah.
4. That's interesting. What do you think that process ID is?
How fast your computer ran it?
No, that's a good question. Process is not like processor time would be how fast you ran it. A process is a thing that's running on your computer, and when they start up, they're given a number. It's like an ID. You know when you show up at the DMV and they give you a number, so you can just sit around and wait? Try this out. Go down to the bottom of the taskbar and right-click and say Task Manager. You'll get a window that looks like this. And I want you to hit More Details. Okay? And you're going to get this thing that looks like Task Manager, and it's going to say Processes. And to this gentleman's point, he was talking about how fast it's working or how it's thinking. You can actually sort by CPU. I've sorted by it, and I can see how much of the CPU is being used right now. By which process, by which running thing. Look, Visual Studio is there, right there. So you can see Visual Studio, you can see Windows Explorer, and a bunch of other stuff you can't see. Just like we use the car analogy, your car is doing a bunch of stuff. Like it's checking the oil all the time, the temperature light can pop up. My car sometimes will tell me that the tire is flat. There's background stuff happening on your computer all the time. That's different than stuff you can see. So there's user processes, and there's background processes. In fact, they actually separate them here. Look, apps and background stuff. I've got 10 apps running. Just click on the word name. How many apps do you have and how many background processes do you have? I've got 10 apps that I ran, and I got 64 things going on in the background. So I can see Chrome is there. I see Visual Studio, PowerPoint is there, that Karnak app that I just ran. Now, this list up here at the top, all these columns like in Excel, right-click on it and say PID. Right-click in that column there, you get a list of things and say PID. What do you think PID stands for? Process ID. Process versus processor. Let's talk about that, right? Processor is the thing that handles processes. Processes are stuff you gotta do. And the processor is the one that deals with that stuff. Processor is the chip, processes are the things that are running here, and the ID is the number that we assigned it, so we can keep track of it. So our app that started up, I'm actually going to go and change it. Let's go and do this. Change your app and add a line that's console.readLine. So your app is going to run, output some text, and then it's going to wait for you to push a key. So all I've done is I've added console.readLine right here.
Okay, thank you.
So our app's going to start up, do some stuff, and then wait for somebody to push a button. So what we're doing is we're leaving the process running. Because before, when we ran it, it said, oh, process has exited. This was like, hello world, and then it was gone. And I didn't even see it in the list. It just said, well, the process with this number, it's gone now. Now, hit Control F5. Again, you could also go to the debug menu and run that, right? We're going to start our app, and it's sitting there waiting. When I push Enter, now it's gone. So I'm running my app, and it's chilling, it's waiting around. Switch back to the Task Manager, and see if you can find your app. You might have trouble because there's a lot of stuff going on when we use Visual Studio. So I'm having trouble finding mine. You can see Visual Studio is running things to help me out, and they all get different numbers. Yes, ma'am?
What is the
CISC.
Oh, yeah, that's cool. So you went and you did not a regular run, but you did, did I stop this? Oh, you did a performance analysis. So you did a performance profile and you started, start and stop collection. You clicked this one, and that actually is really cool. It builds a performance profiler, and it shows you like memory over time. It's like you put a magnifying glass on the process and looked at it over time. We'll actually talk about that. That's a good thing that you did that. So sometimes, so this gentleman clicked the menu that was right next to the other menu, and something else happened that was really cool. We'll talk about that in a second. I'm going to go out to my command line again, and I'm going to run my app. Remember how we said we can get lost sometimes and get confused about where our things are? Over here in the Solution Explorer, where you've got the name of your program, right-click on it and click Open Folder in File Explorer. And what you should get is your actual stuff. Remember we talked about the difference between the logical view and the live and what's really happening. So I right-click on the project, Open Folder in File Explorer, and it's going and telling me where the real stuff is. I can actually see that folder now. And you can go in there, into bin, debug, and find your app. And there's my app, right? I'm going to slow down and we'll go and try to do this ourselves. And I'm going to run my app. And I'm going to find it in that list. So I want to go to Task Manager and see where it lives. You can see how each one of these gets a number. And you'll learn about this when you start learning about operating systems. But it's useful to say because you might have a program that you can't stop. And it might say process with ID 999 can't be stopped. And if you're on Linux or another operating system, you'll say, can you kill the process? So for example, I've got my app running over here. See it's running right there? I can find that app and kill it by hitting End Task. See how it just poofed? I found it in the list and I hit End Task. I didn't warn the app, I just smacked it and it died. That happens sometimes. You'll have to do that where a program that you wrote just goes forever. We could make our program go forever accidentally. Let's do that. I'm going to go to console.writeline here in my app, and let's say I'll make a while loop. So type the word while, and then hit tab twice. So I'm saying, I want you to run this, while something is true. You type while, tab, tab, and notice how it expands it. I typed while, and it went, whoop, and it like made me a space here. I could have typed it, but it did it for me. And then I want you to take right line and put it inside the while loop. See those braces are like very friendly? If you click on one of those braces, it's subtle, and you can change this. You see how it turned gray and it found its friend? You might find yourself, one moment, you might find yourself in a situation where your braces are all boogered up. And you'll be like, I don't understand what's going on here. And you can actually change the brace color to go and find its buddy so that they match up. Yes, ma'am?
I just had a question, just as a point of reference for myself.
Please.
I used to do web page development many years ago.
Yeah.
And, so, and back in the day, and I took a course at UCSD Extension, HTML. And the HTML is just like totally different randomly at the opposite ends,
Of
or
course.
is it
So,
how do you relate?
okay, that's a good question. So she's asking how HTML relates to something like this. So HTML makes a declaration. It like says, here's what the page looks like. HTML doesn't say, here's the instructions on how you should make this page. So the difference, sometimes people call HTML a programming language. It's not really. HTML would be like, hey, this is the title. I'm going to say that's the header, and that's the end of the header. That's a declaration. I didn't like give you instructions. Go here, turn left, do that 5 times. The difference is declarative programming versus functional or programmatic development. We're giving instructions. If I drew a picture and said, go here, turn left, and it's here's the map, and there's a line, and it says this is how you get there. That's declarative. If I said, walk 20 feet, turn 30 degrees, walk, that's programmatic. That's a great question. You see the difference? No one ever explains that kind of stuff. Now, let's say that I've boogered this all up, and now I'm in a panic. That basically looks like most of my assignments. Do you think this still works?
Yeah.
Yeah. Some programming languages care about white space. White space is the space between stuff. And you can turn on white space if you want to see it.
Render view white space.
Did I miss it? Where is it? Oh, boom. Look at that. Now, here's where we get real. One of the great religious arguments about programming. Tabs or spaces. You want to get fired is just say the wrong thing to the boss because they like, oh yes, well you have to have tabs or you have to have spaces. Some people believe you should go tab, 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 tab. And other people say, no, you go space, 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 space. So sometimes people will want their code formatted a certain way. In Visual Studio, I can go back to that editing menu there. So edit, go ahead and mess up your code a little bit. Don't delete anything, just change the white space. And look what you can do. Format document. That's the like, I don't even know, it compiles, but whoop, put it back the way my company wants it. See? So, here, go ahead and click right here. Go ahead and click right there. And then let's hit delete a couple times. See how you've moved that, not backwards, but delete. I think you're on the wrong keyboard. There you go. So you've changed it. Go edit, advanced, format document. See how it puts it back where it was? So Visual Studio knows how it wants to work. Now you might go to a company and they may say, you know, we do everything like this. Because we're weird. And they want everything that way. I'm going to turn off white space. Edit, advanced, white space. You see? And they might say, we want everything like that. And that's fine, whatever. Like, some people want two spaces after a period. Some people want 1 space after a period. They're wrong, but that's fine. Let them have their religion. Right? I'm like, don't eat pork, but if you do, here are some great recipes. That's fine. Same thing comes with programming. Yes, sir?
One of my favorite quotes, I'm not sure who said it, is that the great thing about standards is that there's so many to choose from.
Yeah. People come up with standards in programming, and they say, you know, there's like 10 standards, and we're going to have to figure out which one's the right standard, right? What are we going to do about these 10 different ways to write code? Let's make an 11th. That's just life. Just like we talked about at the very, very beginning, for those of you who weren't here, is that you're going to interact with people who are going to think that their language, their environment, their operating system is the thing. And I was joking with this gentleman here, we were like, why don't the Portuguese just give up? Their language isn't going to win, right? Spanish is what's going to happen. Why don't we just, Portuguese, give up? They like it, and that's okay. There are languages, really obscure programming languages, that you will never use. but somebody likes it and makes money with it. So what is your favorite programming language?
The one that'll solve the problem at hand.
Ask me what my favorite programming language is.
What's yours?
The one that gets me paid. I don't care. Seriously. I like this one. It makes me smile. I feel powerful when I use C#. Find the language or the platform that makes you happy. But don't let anybody tell you that your language isn't going to win. Because it doesn't matter. It makes you happy. Now, I've got a while loop, and I'm saying while something is the case. Is true always going to be true? True will be true forever. So I'm going to say while true, while it's the case that true is true. I could even go, hey, is true true? Let's run it. Right? That's what you should have running. This is what is called an out-of-control process. This process is going to go forever. Now this one will run forever and ever and ever, and probably won't crash the computer. It's just going to take time. It's basically background stuff. If I go over to my task manager, and remember that sort by CPU? It's just going to sit in the back and do stuff, because I made a mistake. So I can do a couple of different things, right? I can stop it by closing that. I can figure out its process ID and smack it manually. But fortunately, since I'm in Visual Studio, I can just stop it by closing the window. Or if I was debugging, I could stop it from here. Let's do this. Click on this line here, click on your console.write line and press F9. If you don't want to press F9, click on the left-hand side in the gutter, in the margins, or what's called the text gutter. It's called the gutter, not out of disrespect for the text editor, but because it's literally, this is the street and that's the gutter on the side of the street. And make a breakpoint there. And you should be able to hover over that breakpoint. And it's going to give you a number. It'll say like, oh, yeah, I set a breakpoint on line 17 of program main, whatever. And then instead of hitting Control F5, I want you to hit F5. And different stuff is going to happen. And see if you can get your computer in a state like this. So this is, and we'll stop in just a second, I realize it's going long. This is interactive debugging, right? So in this case, before when we were hitting Control F5, we were just running our app. We were just like, woohoo, and the app was out of control, doing its own thing. In this one, we actually have strings on it, like a puppeteer. We've actually done what's called attaching a debugger. This is not C# specific, this is not .NET specific, this is computer stuff. Python, Node, every language has a debugger, and the only difference is this app running untethered, or do I have strings on it? And I've stopped it. We've paused this thing. It's like that. It's frozen. And we're at that moment. Now, in the corner here, in the upper corner, you should have, where is it? Some icons that look like this. You hover, move your mouse over them, and you get a tip. You're looking for the 3 buttons that say step into, step over, step out. You find those buttons? They might look a little different on some computers, and it's usually F8, F9, and F10. Why do you think they put them all together like that? It's like copy-paste. It's something you would do a lot. So, I'm sitting on console.writeLine. I can step over it to the next line.
Which would have it happen.
Which would make it do. Let's do that. Let's do that. Let's step over. I'm going to hit F10. And now I'm on the next line. Look at that. This is interesting, because you were talking, sir, about processes and processors. Look, it took 4 milliseconds. It actually told you how long it took to run that thing. 4 thousandths of a second is how much time we spent saying hello world. So we just did a step over. If I had a function or a thing there that I did some work on, I could step into it and go deeper and deeper and deeper and see what my stuff is doing. I could have a function. I could step into the function. Exactly. So now, I want you to do this. Hit F10 and just go like this. see me running my app real fast? See what's going on right there? I'm just like, F10, F10. I'm just running my app. You can step through your apps interactively and see what's going on, and then you might see this thing pop up that says diagnostics tools. That's really cool because it shows you, is your app using up too much memory? Is it doing the wrong stuff? It's a dashboard. It's a performance dashboard. You can drive your car without looking at the speedometer or the RPMs or any of that. But some people, some personalities like that. I like it when I got the little tire pressure thing just in there. I want to know my oil. I want more dashboards. These are all optional dashboards, but you can do that. You can see how your program works. So when you're debugging, and you were doing this earlier, this gentleman pushed the wrong button, and he, rather than debugging, did what's called profiling, which means I want to look at all the little details. I want to have you measure every step, so then I can look at my program and make it faster. Sure, so if you're a game developer or a mobile app developer, and you're like, you know, everything's great in this game, except when they go to the forest, and then it gets slow. Let's profile that app and find out why the trees cost so much to draw, or whatever. Does that make sense? This is where an integrated development environment gets useful and a text editor gets less useful. Now, all these things we've been doing with hotkeys can be done with buttons, and we can just hit stop. Let's hit that stop button, and let's take a break. Otherwise, I'll talk for another 40 hours. Is that okay with you?
So,
Are you finding this useful, though?
yeah.
Yeah.
What I'm thinking, so it's 10:20. Food's gonna be here shortly.
Shortly? For real shortly? Like
For
brunch?
real
We're having
shortly,
brunch?
yes. For real shortly, not like in an hour shortly, like in like 20 minutes shortly, okay?
Oh, well, we could keep going.
Well, so what I was thinking was, maybe we do a video of ML to set up,
That's a pretty big
no?
shift in context, if you don't mind.
Okay,
I think that's,
yeah, well, because I was thinking that then when we come back after lunch, we'll do some of the higher level stuff.
let's do this, if you don't mind.
No,
Let's
totally.
do a bathroom break.
Okay,
And then let's do a couple more things here until the food comes.
cool.
And then we'll
Do Q&A
reset, And we do Q&A when we eat.
Yep,
Are we allowed to eat here, or are we gonna go somewhere?
right next door.
We're gonna go next door.
Yep.
Okay, so quick potty break. Company jump a year in the future. So we've been showing basic debugging, basic language stuff, and you can all go, if you want to, up to .net, it's a website that we made. And we'll put all of this on the college tour. If you hit .net/videos, .net/videos, I've put up dozens and dozens of videos. There's about 100 of them. They're about 3 minutes long. So it's done as a playlist. C# 101, .net, web pages, making mobile apps, making desktop apps. And you can go and learn that stuff if you want to. It's all on YouTube. It's super chill. And we'll talk about like here's me and my friend talking about strings. And we're putting together, and she's teaching me how to make strings, and we'll do like a nice Mr. Rogers Neighborhood kind of thing. Okay? So go and check that out. Those resources are all available. But what we want to do is talk about, once you learn these languages, you learn C#, you can make Android apps, iPhone apps, Nintendo Switch apps, PlayStation, Xbox, whatever. And you can also do what's called machine learning and artificial intelligence. And this is an area that you're passionate about.
Yeah.
So we want to show that afterwards. Now, I don't want you to freak out, because it's going to be like, well, we just went from Hello World, and now we're making Skynet, and you know, it's a lot. So bear with us and hang in there, because I don't want you to think we're going to go from like point A to point Q.
And when we talk about the higher level stuff, we're not going to go into like every line of code that writes this thing. We're going to We're going to talk about the concepts. We're going to talk about like what the heck is machine learning versus AI. Like, how can you make a video game? Unity is a free tool. I want to show it to you and have you like know that it exists and that you can play around with it, and that there are sample code that you can copy and paste. And I'll show you how to do that and get something working. And then
Right, so the idea here is that a language like C# and a runtime, .net, which runs the C#, is the base of the pyramid. But what we want you to do is kind of stand in your own power. Get the fundamentals, get the for loops, get the variables, get a sense of how the computer works, open up Task Manager so you don't get surprised that the computer's doing something. And then imagine as you build those layers and you build those layers, as you've learned to drive a car and now you're a race car driver, you could go and do a website that advertises your mobile game that has a back end that does machine learning. And you can do all of that with the fundamentals that you're learning. We want
And
you
the
to
neat
have
thing
that
is
power.
that you can do all of that within the .NET framework, or you can mix and match, or you can do it completely outside of the .NET framework. Again, we are passionate about it, but we're not here to convert you. And so take what you learned here, the hello world, you can do that in Java and BlueJ, right? You can do that in Vim if you wanted to, in whatever language, Python, right? So you can do all of these concepts, and these higher level concepts can be done in anything. But the neat thing that I love about .NET is that if you learn that, you can do everything.
Right. And
Without having to learn another
remember
language.
also that the thing that you all need to learn here is how to learn.
Yes.
That's what you need to get. Like when you are thinking about like, why am I even doing this? I'm this many years into this journey. Why am I even trying? Don't try to learn all the keywords, all the details, but also don't think that you can just Google your way into a job. Get the fundamentals, but a for loop is a for loop, a while loop is a while loop, a process is a process. These fundamental things about how the internet works and how computers work will allow you to do things like machine learning that we're going to talk about. And we'll also hopefully answer some questions about what we hear people on the news talking about artificial intelligence and how they're just really bad reporters and they don't know what they're talking about and what reality looks like. So we'll do that after lunch. Cool?
And during lunch, so we're gonna move over to the next room, food and drinks are over there. You're just gonna like sit and eat, and during lunch, I'm gonna talk a little bit about life after school skills, internships, interviewing, your first job, and then we'll do a little bit of a Q&A, so then that way if you have any questions about us and our journeys, or people that we've mentored, or people who've mentored us, you can ask them.
Will this room be locked? Can we leave our stuff in here?
I think you can leave your stuff in here.
I lock the room.
You're gonna lock the room?
Yeah, I will lock the room.
You will lock it, so I'll do everything and you lock it. Alright, cool.
And we'll just move over there, and I'm gonna grab my computer just in case. It's not because it's better.
This is faster.
No, it's because 15 years ago, when I was first learning how to code, I needed to be on like a Unix terminal, and it was embedded in Mac at the time, and it wasn't in Windows at the time, and so it was just easier for me to do that, and then I just got stuck with that ecosystem. And I'm trying to start
Now they're
practicing.
pretty equal.
Yeah, I'm starting to start practicing on a Windows device because there's just a lot of things that it has that Mac doesn't have that I need to personally use. So I'm starting to try to practice, but I'm very clunky on a Windows device. So I'm trying to like, yeah.
Let's see if this audio works. Run this video.
Okay.
Which is the process whereby we take data and
It is. All right, good. Okay. So we're gonna up level now and think about stuff you can build on top of this. Now, we didn't get a whole lot of time to talk about functions, right? But a function is fundamentally inputs and outputs. Either you wrote it or somebody else wrote it for you. So if I wrote a function, go to the store, and inside that function it had like, go 20 feet this way, turn left, da da da. There's a description of the directions of how to go to the store. Just like our friend who was saying, you kind of roll and then you're at home, right? You have a function, you had to go home, and you just get home. You don't think about the little details. If I said, go home, and you literally had to like lift up your right foot, like you can get down to the low level stuff and just don't forget to breathe. There's all these things you have to do in order to get to where you're going. You wrap those things, and you wrap those things, and you wrap those things until it just becomes go home. You have to be very specific though when you give a computer instructions or a person. There's an old programmer's joke where a programmer asks his wife, who's also a programmer, hey, can you go to the store and get me some bread? And if they have eggs, get 12. And then she comes home with 12 loaves of bread. And he said, why did you get 12 loaves of bread? They had eggs. Go to the store, give me some bread. If they have eggs, get 12. I thought you meant 12 bread, not 12 eggs. Programmers are real specific.
And why are programmers real specific?
Because we have to be, because the computer does exactly what you tell it to do.
The computer would have gotten 12 loaves of bread because, you know, maybe, depending on which
Gotta
language
be
you're using.
specific, right? So if the thing doesn't work, you gotta do it. Now, that's an example of a function with a bug that we then fix. Now, machine learning is really interesting, and correct me, because you get the PhD, I want to try this. Machine learning is where the machine learns how to write the function, where I might say, okay, here's my house, and there's the store. Here's a picture of you at my house. Here's a picture of you at the store. You figure out how to get there. And then it learns and it learns and it learns, and it tries stuff. And it literally might start from the first step, like the very first time we try to do this function, it's like, and then it has to learn how to walk, and then learn how to drive a car. And generation by generation, it learns to eventually make it to the store. And then it might have this wacky thing that like makes them go to the store like this, but that's the one that it learned.
Yeah.
And then it wraps it all up into a function that says, go to the store.
Yeah. And one thing, I get this question a lot. I am not a PhD in machine learning or in AI. It's in computer science with focus on education. I've been dabbling in the other two, though, recently, so I, take that with a grain of salt. However, the way that I like to explain the difference between AI and machine learning is that AI, this is a super high level, does what you could do today, right? So if I showed you a picture of a dog and a picture of a cat, or sorry, if I showed you a picture of a dog and I said, is this a dog or a cat, you'd say it's a dog, right? AI can do that. It's an artificial intelligence. Machine learning would say, here are 10,000 pictures of different animals. Can you classify these into different ones? A human could do it. It would just take a really long time, right? Because there's lots and lots and lots of different variables. So you're teaching the machine how to look at all of the variables and make those decisions that a human can make, but just a lot faster on a lot larger scale.
So artificial intelligence can do like tedious stuff, like look at that,
Right.
like that. Machine learning would be like massive things. You're like, I know there's a pattern here,
Right.
but I'm not
What
really
is
sure.
this
I can't really
pattern?
see it.
Yep,
Figure it out.
exactly.
I thought machine learning incorporated, I thought artificial intelligence incorporated machine learning.
It does.
It does, yeah.
Because the artificial intelligence we have today, it's really easy to use. They're like, APIs that you can just call into and say, hey, Azure, what is in this picture? And
We'll
it'll
show
tell
you how you can do this
Yeah.
in like 5 minutes.
Yeah.
So like there's basic stuff. Like in the old days, if you wanted to write some code to open a picture, you'd have to write that yourself.
Right.
Now there's a library, and opening pictures is not a big deal.
So in the old days, 5 years ago, I don't know how many years ago, in the old days, if you said, hey, computer, is this a picture of a dog or a cat? There was someone who had to write the machine learning algorithm to say, well, I don't know, like, is this a picture? And actually, like a long time ago, there were these like Google games where you would say what's in the picture, and they were training their models to say like, hey, and we'll explain a little bit about what training models means, but hey, this is a dog, this is a dog, this is a dog, this is a dog. Now, AI says, oh, I know what a dog is.
Google's doing that, when you do that like, are you a robot?
Yeah,
They're getting your free labor.
yeah, like click on the square that has a light in it.
You know why they do that, right? You're teaching their computers to recognize those things. When it says, is this a crosswalk? Why does Google need to know that? So they can make Google Maps better. And you just gave them a second of free labor. Have you ever heard of a mechanical Turk? Okay, the mechanical Turk was an actual thing in the early 1900s, late 1800s, where someone would go to this amazing robot. It was like a big table with a Turkish, kind of a stereotypical person with a turban. It was meant to be a Turk. And they would ask it questions, and it would move cards around. And they thought it was the most amazing technology they could ever imagine. It was a dude in a box moving the arms of the robot. So you can go and do amazing things on the internet where it's like, yeah, figure out if this is a dog or a cat. You don't know if the computer did it, or if Amazon just hired a bunch of people and paid them 1 penny to click on dog or cat.
You can go to the Mechanical Turk
There's
website
a product
today.
called the
and get
Amazon
that
Mechanical Turk, where if you have a bunch of work, you can pay them, I'll give you 20 bucks, and then they will go and pay fractions of pennies for humans to do the work and tell you a computer did it.
So yeah, so machine learning is in a lot of things. For example, I got this Apple Watch for my birthday, and I sometimes fall, and then it'll say like, hey, did you fall? Do you want me to call 911 for you? And I'll be like, no, it's okay, it's fine. And then it'll say, but wait, did you actually fall? Or was it something else? Right? Because it's now training, and it can potentially, I don't know what it is in the back end, I think it's training a little bit to me,
Yeah.
it's mine,
What
right?
falling looks like.
What falling looks like to Sarah. Sarah is 5'1" and falls often. Adrian, my husband, is 6'7". A fall for him looks different than a fall for me, right? And so it's probably saying like, hey, wait, did you fall or did you just kneel because you're 6'7", right? Because like, you know, accelerometer for me looks a little bit different. So anyways, there is some machine learning behind a lot of what you do.
Right.
It's just that as application developers, if you're not building the AI, but you're integrating AI into your app, you're integrating that higher level of like one call. If you're integrating or building machine learning, then you're doing something on a larger scale.
Do you have a question? Good. Okay. Additionally, the idea of software that adapts, that changes. Her watch will be smarter about her falls. One of the things that's one of the things that makes me interesting is a hidden disability. I'm type 1 diabetic, and I have an insulin pump, and I've got medical implants, and batteries, and open source hardware and software, all keeping me alive. And it tells me patterns. It looks like your blood sugar goes low on Tuesdays at 5. That's when I do Taekwondo. Hey, I'm going to change how your pump behaves and give you less insulin so that you won't go low on Tuesdays at 5. That's machine learning. So those kind of things are like real world problems where it could make, theoretically, this disease, this chronic condition I have, go away.
Yeah.
That's why we want to think about the positive things about machine learning and not just like whether a cat and a dog can be figured
A
out.
silly version of that is I work from home, and so every time I get in my car, my maps will come up and it'll say, hey, are you trying to go home? And I'm like, yeah, I get it, okay? I don't go anywhere, I get it. You don't have to rub it in my face.
That's an example where a machine learning algorithm can make you feel better.
Yeah.
Without even thinking about it.
From a career perspective on machine learning, so a person who does scientific study of algorithms and statistical models,
Yeah.
would that person be called a data scientist?
That's a
Great
good point.
question.
That's a great point. So it depends, right? A data scientist could be the person that does the mining of the data, comes up with the questions. They could go to a machine learning specialist who might make a piece of that function.
It's
Right.
a separate function.
It depends, right? Like if she and I are working on a project, she's the imaging expert and I'm the machine learning person. She writes the algorithm to do the imaging stuff and I do the data. We can separate the work however we want to.
From a career perspective and a resume perspective and an applying for jobs perspective, it is a hard problem that the industry hasn't solved yet.
The titles.
And the titles, we're working on it, right? In that there are data analysts, there are data scientists, there's an AI engineer, there's a data engineer, there's a machine learning model expert, there's, you know, all of these things, research scientists, there's subject matter experts who know what the data are, who are an extremely important part of building a machine learning model.
Use your husband as an example.
So he's a bioinformatics scientist, okay? So he writes code to solve biological problems.
He's not a doctor.
He's not a doctor, he's not a biologist, he took some courses in biology and some in computer science. He works with pure biologists, and he works with pure computer science machine learning people. These two people don't know how to talk to each other, right? And it's not just a social thing. Like, they don't know how to talk to each other because they don't speak the same language. These people are talking about proteins, and that's the extent of my knowledge.
That's all you know protein involved.
And these people are talking about Kubernetes and whatever, right? And so it's interesting. He comes to me every day, frustrated, and he's like, I was on this call, and the machine learning guy said, we just got this thing 5% more accurate. And the biologists are like, we're not using that because it's not predicting the right thing. And he's like, I don't know how to get them to tell each other that, right?
That is his job.
It is exactly his job. And so it is a difficult problem. And what I will say to that is apply, ask the questions, see what it is that the skills that the person who's putting up that job is actually after. And you define what your skills are. I don't think there's really been a job that I was, here's my resume, that's exactly my job title. It's always been, I'm good at these things, this is what I want to spend my time on, let me find a job that fits that.
Sorry.
No, that's fine.
Crisis at work.
Any questions about that? In fact, that's like my new task at work, is I'm trying to define what Microsoft's opinion, this is not truth, it's Microsoft's opinion, is of that entire data ecosystem.
People are trying to figure out those things, but you'll also find that even now with software engineering, which is a 30 or 40-year-old thing, people can't decide what a junior engineer, a senior engineer, and a staff engineer are.
I like to compare like data science and machine learning and all of that to what like a web dev was, you know, however many years ago. I'm a web developer. Oh, great, you're hired. Are you going to build the front end? Are you going to build the back end? Are you going to focus on the networking? Like, what is it that you're going to be doing? Nowadays, we're like, okay, I am a full stack developer, or I am, you know, focused on the databases. I am focused on the user experience. I'm actually the one drawing the designs, right? We understand now and to develop one simple website, you need a lot of different people, right? With a lot of different skill sets, or ideally, you should have that. It's the same thing in data science and that entire data ecosystem.
So what we did here is, this is actually a demo that I'm going to give at a conference next week, and I'm going to be giving a talk talking about like all these developer things and how they fit together. And the gentleman who's going to do this video, it's about a 6-minute video, and we'll stop it and pause it and talk about it, is a data scientist, and he wanted to do a problem for me, and the problem is really stupid. I made a video game for my talk that is rock, paper, scissors. But it's the complicated version of rock, paper, scissors. It's rock, paper, scissors, lizard, Spock. And you may have seen that on Big Bang Theory. It was actually invented on the internet, and the Big Bang Theory stole it from some very nice people. And the idea is that with rock, paper, scissors, it's easy, right? Like rock crushes scissors, right? And like paper covers rock, which never made any sense because rock would win everything. And then like rock breaks scissors. Those are the 3 rules. It's super easy, right? But if you add 2 more things, Spock from Star Trek and lizard, suddenly the combinatorics, the combinations are huge, and it's like paper disproves Spock because he's logical, and Spock shoots rock with a phaser, and you know, scissors cuts the lizard's tail, and like it becomes a whole thing, right? So we wanted to do 2 things with machine learning. We wanted to first see if people have patterns. Do you ever have a friend or a brother or sister you play rock, paper, scissors with, and you always crush them? Because you don't know it, but you're doing machine learning in your head, and you know that they go rock, rock, scissors all the time, but they just don't know it. And you've intuited it. Your intuition is like, I know I can always beat them, because I know that they're going to do scissors and they're going to do rock. So he built a machine learning algorithm to beat people at rock, paper, scissors. So we'll watch that video, okay?
Thank you so much for that introduction. We are going to talk about machine learning, which is the process where we take data and compile it into algorithms called machine learning models. The cool thing about machine learning is that it looks at patterns. And what better way to exploit patterns than to look at a game of quote-unquote chance? Because it turns out that humans, we love patterns and we sometimes stick to them too much. And it turns out that, Scott, we've been watching you play rock, paper, scissors with your consent, and we found a particular pattern of thing that you follow, which is pretty interesting. Now, if we were just to pick, for example, rock, using your tendencies, we would be right about 40% of the time, which is pretty good.
Sorry, real quick. Do we understand like why he said that?
Which part, the consent part?
No. So this is what you are doing, right? So you've played rock, paper, scissors X number of times, this number of times. You did rock the first time, you did paper the second time, you did lizard the third time, right? You played it that many times. And then he said, okay, so if I were to say you just did rock, and I were to guess, I would be right about 40% of the time.
So
based on this pattern.
This is what he observed me doing, and I'm saying paper after rock some number of times, right? You said 40%.
Yeah, although it looks a little bit different than that. It looks like you always do paper after rock, but...
Well, but then there's other
rocks. Sorry. So the 40% is, I think, because if I randomly guess, I think is what he's saying.
Oh,
If I randomly guess, I would be right 40% of the time, because you always do paper afterwards. So if I randomly guess what you would do next, not using machine learning, right? Just a random guesser, I would be right 40% of the time because you always choose paper.
Right, okay, that makes sense.
Yeah.
But we can be even smarter when we look at the sequence of things that you play. It turns out every time you play rock, you also play paper, which is great. But if we go even one more further, turns out every time you do scissors and paper, then rock is sure to follow. But notice that paper doesn't always predict rock, but it does when there's two.
So you see how we suddenly went SPR, SPR, SPR. So I'm going scissors, paper, rock, scissors, paper, rock. I don't even know what I'm doing. No normal human would ever figure that out, right? But computers could.
Yeah.
When you hear about a computer saying that they can recognize someone based on how they walk, or if you see like a blurry surveillance video and you're like, oh my God, my cousin just broke into 7-Eleven. I recognize, it's blurry, but I can see how he moves because that's how he moves. That's stuff where you know it because you feel it, but you can't really put your finger on it. The computer can actually build a tree that describes
And
that.
notice what he said. So if you do rock, I can always predict you're gonna do paper, right? But if you do paper, it's not always rock. But if you do Spock paper, it is always rock. So if I see you do Spock then paper, I know the next two, you're gonna do rock then paper.
He needs to.
Because I know you're gonna do rock.
He's got S and he's got 2 S's, Spock and scissors. We gotta fix that.
In that order. Now, here's what we're going to do. We're going to exploit that, and I'm going to show you how we've done that. Basically, we keep track of every move that you make. We count how many times you've done something, but we also...
So this is JavaScript. This is called JSON, JavaScript Object Notation. It's just a way to describe data. So like HTML. It's like HTML except it's using curly braces or mustaches. If you turn your head like this, it's like a mustache. Where that one matches up, this one matches to here, and this one matches to here. So it's like, here's a rock. You did it 4 times. You'll probably do paper or Spock next. Does that make sense? It's just a way to describe data in text.
how many times you've done something, but we also go even deeper and say, anytime you've chosen lizard, what have you chosen after? It looks like only rock. And then we've done even a smarter move, and it looks like every time you've chosen lizard rock, then you've chosen Spock. So basically our machine learning model is a glorified counting machine, and anytime you do something, we look at the sequence of things that you've already done, use our lookup table to see what's the most likely thing to happen next.
So he's not like building some crazy machine learning model in, .NET and is putting it up on Azure or whatever, right? He's got just a JSON file with just this information that then when you do something, he's gonna look it up and say, okay, I think you do this, right? This is the basics of machine learning. This is a version of that. It's not the one that predicts the 5 pollens, but it is the first step, that first brick.
All right, well, what if we want to do something even a little smarter? It turns out that in our game, you can actually use a webcam and put your hand in front of there so that the machine can actually predict what it is that you're showing. Now, in order to do that, just like we had to get sequences of the actual signs that you threw, we also need to get physical pictures of the signs that you decided to show.
Why do you think we need physical pictures of the signs that you decided to show?
So compare and contrast between the two.
Okay, yeah, and why of yours?
Because you're the way that you make
This is how I do rock, this is how you do rock, this is how the other person does rock, but this is how the other person does lizard, right? So we also need to train some of our data ahead of time. That's part of it as well.
Or so that we get examples of how to show the signs. So in order to do that, I built this little cool app here in JavaScript. And basically you can see the model acting there right now. You can see the paper, scissors, right? So it's pretty good.
Look here. See right there? It's a guess, right? It's never 100%. He can't be sure. When we trained this, we were goofing around and we made a mistake and we forgot that nothing is a thing we need to train. So it thought that anybody with a head was a rock. So we had to go and add none as a thing. So it's possible that could be a lizard. We don't know. He could also be a rock. We don't know, right? We can't ever make assumptions.
Pretty sure.
That was good. And basically, you can see the model acting there right now. You can see the paper, scissors, right? So it's pretty good, but sometimes it turns out that it's not very good. So in order to collect more images, I'm going to go ahead and press the space bar. Oops.
So he's going to say rock, and he's going to...
I'm going to go ahead and press the space bar, put something in there that says a rock, and then be able to submit.
So he's training it, and he does rock like that. That's freakish.
And did
Nobody
you
does rock
notice
like
though that he was doing
That's
this?
rock.
Yeah.
Right? Did you notice he was doing this? When you
He's
have,
mixing it
if you
up.
have like an iPhone or something and you do the Face ID, you know how it like makes you like do this, right? Because sometimes I'm laying in bed and I take it like this, and sometimes I'm like, and sometimes I'm like, right? So it needs to have enough training data. That's all a machine learning algorithm. It needs to have enough training data to know that's still me and not someone else.
Training examples, you're wondering, well, where does this go? Well, locally, I'm using a handy-dandy Azure function to take this data and push it into, you guessed right, custom vision.
Azure Functions is just a website. So you know how you go and you fill out a form, put in your credit card number, you hit submit. It does a post and it sends your data. All he's doing is he's sending those images and the word rock with some percentages, and he's posting it to a website. It's just not a website you can see. It's called a web service. You heard that she said the word API, application programming interface. An API is just a function, a thing that you can call. So a web API is just a function on the internet.
So let's go over to custom vision and let me show you what I've just done. If I go to training images, you'll see the images I literally just put up are in there. What this will do is as people submit pictures, it will learn a model. And to train it, you basically click on train, and that is it. Now here's the cool thing. If you make certain...
So here he thinks that he can do precision about 90%.
So should we talk a little bit about what train means? So he kind of glossed over that part, like, okay, and then we just click train and it's trained.
I have it all set down,
Awesome.
so I'll be right back.
Okay, sounds good. So one piece to that. So have you ever heard of the training and testing data? A little bit? No, maybe? So this is how it works in data science, machine learning, I don't know, whatever term you want to give it. So basically, you have a bunch of data, right? The data that he has is that big list of all of those pictures, right? And you saw that he did his rocks, but then there was also some other people who had done other ones. That is our training data. It's training data because we have the picture, the thing that we're going to get in, the input, and we know what it is on the output. We know this is rock because when he was building up that data, he said, hey, this is rock. That is our training data, okay? Our testing data, when we're building a machine learning model, is the data where we give it a picture and we say, now based on that training data, guess what this is, okay? And then there's this whole thing about overfitting and all of this stuff. It's a little bit low level, but basically, if you give too much data ahead of time, then you're always going to predict kind of like exactly what that data is. Let me pause for a second because I didn't explain that very well, and I want to get a better explanation. So if you have a cat, picture of a cat, just like a normal, let's say black cat, right? So I have a black cat at home, her name is Princess, and I just have like 501 million pictures of Princess, okay? And then I've got a picture of an elephant, okay? And I tell my machine learning model, this is a cat, this is an elephant, okay? And then I train it, and then I send it a picture of Princess, and it's like, cat, got it, cat, that's what it is, it's cat, right? And then I send it a picture of my other cat, Luke, who is a gray tabby. It might be like, that's an elephant. 4 legs, a tail, gray, totally an elephant, right? Because the data that I gave it was too fitted to one solution, right? So if we always did this, rock, 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 this is a rock, this is a rock, and then someone did this, oh, that's not a rock, don't know what that is, right? So you have to be careful. You want your data to be diverse, and you want your data to be representative. And this is where ethics comes into machine learning and into data, right? If you are having, if you're having some kind of like app that, oh, this is a good one. This just recently happened to one of my colleagues, okay? So they were building something, and it was trying to detect whether or not you had an object like in your hand, I think it was, okay? So it was trying to detect whether you had an object in your hand, and it was like object, no object, object, no object. Okay, this is embarrassing. Everyone who had done the training data were men, and then this woman comes up and says this, but didn't have an object. And the algorithm said, object! That's an object. And she was like, nope, just my boobs. And it was really awkward because she was a junior engineer and her manager was there, and all of a sudden the thing was like, object! And it was like, no, it's not an object, right? So diversity of all kinds, whether it's cats and elephants or people, in your data is very, very important, because you don't want to overfit your data to the wrong conclusions, okay? So the training data is all the data where you say, this is the thing, and this is what it is. The input, and this is the output, okay? You've got your testing data, and that's where you actually do know, here's a rock, but you're not telling your model that's a rock, okay? You know it is, but you're not gonna tell your model it is. You're gonna ask your model to predict. And then your prediction score is how well did it predict that, okay? So you've got your training data and your testing data, which gives you your prediction score, and if your predictions are good, then try it out in the real world, where you don't know the answer, right? And then the troublesome comes is if you have your training data and you have your testing data, and you're constantly trying to get that better, well, your machine learning algorithm is learning, and so now your testing data isn't actually testing data, it's part of your training data, and that's another problem, right? So there's a lot of problems with it, but when you talk about data science and machine learning, it's training data and testing data which will yield your prediction to be able to do it. Does that make kind of sense? And do you understand why like the ethics of this becomes tricky, and why you can get really like crazy headlines out there that say like, oh, Microsoft hates women, and it's like, well, no, just, yes, I mean, like, no, they don't. Yes, there was an early test where there was one engineer working on it and he happened to not have boobs, but we weren't done yet, you know what I mean? So, and it's not just Microsoft, right? This could be you, it could be anyone. But it's just very, very important for you to recognize a few things. One is when you're using something that the person who built it may not have had the most diverse data set. And then two is when you're building it to take that into account. And that's also why, personally, if I see something that's like, I am 99% sure that that's a cat, I feel a little bit better, because it's not always going to be right, right? And so if my cat versus elephant said, yup, that's an elephant, 100%, totally an elephant, I'm gonna be like, I don't trust this thing at all. But if it said, 80% that's an elephant, I'd be like, hey, no, but I'll give you another chance, right? And so sometimes you'll run across apps, or like my watch, where it says, I think you fell, did you fall? Like first it asks if I'm okay, but then it said, but wait, did you fall? I like that better. That's actually a part of the user experience. Not only are they training their data, but it's also part of the user experience to let me know that the watch isn't just gonna call 911 randomly, it's gonna check in with me.
By the way, when we're done with this,
Yeah.
that was an actual, like, interesting problem.
Yeah.
Where my website did something wrong, someone called me freaking out, an advertiser was mad, I had to open up a file, edit it, change it, reset the site, so that might be something we could talk about.
Yeah, totally. We're good to continue.
We are.
Yeah.
Kinds of models, you can actually export them. I've already exported.
Export. Export is a fancy word for save as. You open a GIF, you save it as a JPEG. You open a JPEG, you save it as a PNG. Word doc, Excel, whatever. This is just 5 different ways to export or save as.
Export your model. He took his training data. Now he thinks that with new data he can give a decently accurate prediction. So he's got a machine learning model that he's going to export and anyone can use, right? That sounds super fancy. That's what he did.
All it really means is you need that one for Android and that one for iPhone and that one for Windows.
Yeah.
But it's cool that he can use it everywhere.
No, it
because
is.
he only has to do it once.
To show you side by side, when you're looking at models, it turns out that they're kind of similar, but just different shapes. Basically,
This is a really important thing to think about from computer perspective. That there's multiple ways to do stuff. Like you and I were talking earlier, and he was asking about the command prompt. And we looked at typing dir and seeing a directory, or ls if you're in Linux. And then we looked at the Windows Explorer. And it was like, those are the same thing, it's just different sides. It's like, here's the front of the mirror, here's the back of the mirror. You're just looking at different things. That and that and that are all different ways to express the same thing. Just like when you're on a map in Google Maps, and you can say, I want to see the street view, I want to see the layer, I want to see the terrain, I want to see the out. It's just all the same earth. That looks scary, but it's just a visual representation of that.
Or maybe that
Or
looks
maybe
scary.
that. Depends on whatever. Exactly, great point.
Because it's just a bunch of black and white and I don't know what it says, and this one makes sense because I can follow arrows.
Some people
Yeah.
feel more comfortable looking at one representation than another.
And that goes back into like the roles and who, you know, what role are you? And some people spend a lot of time looking at the JSON and, you know, cleaning that up and Excel files and all that. Some people spend time with the flowcharts and determining, and some people are building them out, right?
is we've looked at a sequence of rock, paper, scissors in the first model and created this model. And in the second model, there is a deep neural network, a convolutional neural network that is used to predict the actual image. Notice that even though they're not exactly the same, they have the same concept. We basically squoze in the data into a compact
That is
representation
not a word.
for prediction.
That is not a word. Squozen, squish.
All right, so it looks like this one was just trained. Looks like
He's trying to pretend that squoze is the past tense of squeeze. And then he did the past participle, squozen, not a word. But this is the thing in computers, people just make a word up. And then if he says it enough, it will become a word.
There's a made-up word in my dissertation title.
Is it?
Enculturate. It's technically not a word.
Enculturate. Enculturate.
Yeah.
That's a perfectly cromulent
It's now a word.
It's a perfect,
Dr. Sarah said so.
perfectly cromulent word.
wasn't as smart as the other one, so what we'll do is we'll export this. And notice that in this case, if we want to use it on the client side, we basically need to download the TensorFlow JS.
So when he said client side, he meant the browser. If you think about client versus server, if you go to a restaurant, you're the client. The server is who's helping you get your food. If you go to a website, you're the client, your browser is. And the server is the one that gets you the web page. So he wants to use it on the client, meaning the browser is going to do the work. So he's going to use JavaScript because browsers are really good at JavaScript.
Model and download it. So as this is downloading, very nice. I'll let that sit over there. You're probably wondering, well, how do we actually use this model to predict? Well, I'm glad you asked. If we go to the actual code for this, you'll see it's very easy to use this because
Okay, let's look at this code here. He's got, I don't speak JavaScript. It does not matter. Because, what has he got there in green? Comments. Good commented code makes it easier to understand. I don't need to speak JavaScript to know that he gets the video and puts it on the canvas. Just like you paint on a canvas, he's putting video on a canvas. I can guess on line 133, CTX. I know that means context because I'm old, now you know it means context. He said get context 2D. That means we're probably doing two-dimensional stuff and not three-dimensional stuff. And he's going to take that 2D thing and paint on it with the video, and it looks like it's going to be 320 by 240. I just guessed that, and I don't know JavaScript.
And also, good comments are not just useful for people learning or who don't know the language. They're useful for yourself when you come back in 6 months and don't remember why you wrote that in that way.
Write the comments for future you.
Yes.
Then he says, run the prediction. Remember that model? Remember she said he made a model. He's going to go and execute that model. Async just means in the background. And then the prediction comes back, and then he's going to go and update the label with that prediction and then a probability. And it looks like he's going to times that probability by 100.
So
Probably
means,
because he's going to get a number like 0.5.
yeah, probability is probably coming back as a decimal, right?
So he's getting 0.5 and he wants to show 50%.
announcing today that the amazing people at the Custom Vision folks have released a new NPM package that lets you literally just load up these models, which is pretty amazing. All you have to do is unzip them and then load them up. So basically you use import here, and then when you want to load the model, you basically create a new classification model.
So he's showing that, keeping in mind about responsibilities, the question was, like, what's the title of the person? Maybe this is the front-end programmer or the JavaScript engineer, and she's the data scientist. She doesn't know JavaScript. I don't speak data scientist. She gives me the model. Now let's go back to the very, very, very beginning of this conversation. A model is just a function that wrote itself. Inputs and outputs. The input is the picture. The output is a guess about rock or paper or scissors. So what I'm doing here is loading the model that I was given and then using it. I'm just calling that function. But it's really important that, from my perspective, it's magic.
And there's a lot of models that exist that you can just use. So if you are trying to do something that is smart, like build a smart app, likely there's probably a model out there that you can try. Just remember, you don't know what data they use to train it.
Yeah, and that means, though, that if you wanted to write an app, like we actually had a person at a community college write an app because a squirrel kept sneaking into the backyard and messing up their flowers. So they made a machine learning model with a little Raspberry Pi, which is like a tiny computer, and it didn't have to figure out anything other than nothing or squirrel. And then they hooked it up to a Nerf like squirt gun, and then they would put a square around the squirrel, and then they would have a motor that would move the squirt gun and shoot the squirrel, because you want the squirrel out of your space, but you don't want to hurt the squirrel. That is a real problem. That's not hard to do, and they didn't even understand machine learning. They just got the model for squirrel, not squirrel.
And load up the JSON file of the zip file that we just downloaded. For me, I put it right here, and you can see that there is the model.json. Now, you're probably wondering, well, it must be really hard to do the prediction, but indeed it is not. So if I go to line 136, you can see I basically just need to say await this.model execute async, and this takes a canvas element that I've drawn the picture in the video of, and then I just update the probability so everyone can see. Now, the cool thing about this is anytime there is a model that's new and we want to actually upload change our model, we can literally upload it.
This is really important. This is about versioning. Think about the relationship. There's the artist that drew the cool graphics. There's the JavaScript person that does the pictures and stuff. There's the machine learning person. We're all working together. We want to be able to make our rock, paper, scissors game smarter. So we made an upload where we discover that, like, I don't know, people with 3 fingers aren't getting recognized. They can't do spot right. So we need to cheat. We need to find a 3-fingered person to fix it. We then upload a new model, and it becomes smarter.
So the one that we just talked about with holding an object, not holding an object, once they discovered, oh, we need to have a more diverse set of people, they were able to, like, they don't have to change the whole app, right? They just update the model and plug the model back in.
And just as an aside, this brings up this idea, we hear the word diversity a lot. It's a kind of a code word. It just means like not white folks and usually not old white dudes. But a better way to think about it is inclusion. And the opposite of inclusion is exclusion. So when we say we want a diverse team, it doesn't just mean we're building a team of Power Rangers. And we all remember the Power Rangers only had like 1 black guy.
Yeah.
You just can't have 2, right? You have to only be a Power Ranger.
Yeah.
That's not what we're talking about. We're talking about if we're making a product for everybody, then it needs to work for everybody, right? So what if a person in a wheelchair is trying to play rock, paper, scissors, and the wheelchair is getting in the way of the camera or whatever? We need to make sure that they're included. So when we take diverse teams, we're talking about every age, veterans, whatever, so that we make a team that works for everybody.
And I use the word diverse when I talk about data sets, and it's a
That's
little
a good point.
weird, only because diverse can also just mean like different, right? And so when we're talking about cat, I want a diverse set of cats,
Yeah.
right? I'm not necessarily thinking as much about inclusion of cats, because they don't know what's going on, but I'm thinking about that diversity. So
You might have a naked cat, you know, those little freaky
Exactly.
looking rat cats
Yep.
or whatever.
Yep.
And you might, it works on the set of all cats that are my cat.
Yes, I talked about that when you left.
Okay, so that's 100% accuracy on
On
your cat.
Princess.
Yeah, nice.
Pretty cool.
That's
I'm
your
going to upload
audience.
this
Yes.
version. Uploading right now, and now when I go over
You
to
can make it
this
smart, just like
particular,
Google photos get smarter.
You can see the
this gets
model that we just uploaded is brand new, and it's gonna be a lot smarter. So if I put a hand here, it should predict,
Oh, you see
let me
right
do
here?
rock.
Here.
Very good. So notice it learned rock.
You see where it's, you can't kind of see it, but it's right there? You've got little graphics. So now he can play rock, paper, scissors with the computer.
Now I hit start battle, and you can see that we've created two machine learning models. One that was more intuitive, that was a compact representation that we pushed to Cosmos DB. So anytime someone logs in, we can see the sequence of things. And then we made a more complicated one using custom vision that actually shows us,
So in this case, machine learning is being used in two ways, the prediction and the graphics, totally different things. It's actually used twice. Cool, I think we'll call it on that.
Yeah. So we're getting towards the end. First of all, does anyone have any questions about machine learning, data science? Yeah.
What do you do when you have poison data? People who
Great
purposely
freaking question.
try to ruin your program.
Yeah, I mean, what do you do? I think, so I don't have like a clean answer because I'm not an expert in this. However, I think it all just goes back to you need to be ethical, and that is a deliberate or intentional thing that you need to do. So there is a whole part, and sometimes this is called like the data analyst of like cleansing and manipulating the data. And when you hear like they're manipulating the data before building their model, it's not like tricking it, right? But there's this whole part of data cleansing, manipulation, and cleaning that gets your data to the point of like, yes, this is representative of what it is that I want my model to be based off of. So what do you do in that situation? It depends, like how are you collecting your data? Do people know that they're doing that? If you're collecting your data from Reddit and people know that you're trying to build something, then you might just need to change how you're collecting it.
Let's talk about, let's be real. We did a sentiment analysis engine. Did you show that at all?
No,
okay.
not yet.
Sentiment analysis is like, is it good or bad, right? And if someone says...
A sentence.
If someone says this, and it's the sentiment,
Yeah,
the feeling that
exactly.
you have about that sentence. If I say this product sucks, that's bad. If I say this vacuum sucks so well, right, that can be good, but you got to teach it that way. But if you used Reddit, which is a cesspool, and you use their comments, it would skew mean and negative and cruel, right? But if you used, I don't know, a Christian forum, it might skew another way. So when we say diverse data sets, we got to mix it up and see what the intent is. And we always have to be changing it, though.
Yep.
You'll never make a model
That's done.
and just be done, because something will change, right? And if we look at like Google Photos, which is a great example where you teach it about your family and what you look like, there's always things that are changing. People's faces change, their age, their lighting.
And with that kind of thing, now I don't know if you've used Google Photos, but it used to be like, I can detect Sarah at age 30, and now it's like, shows me, and it's like, hey, this is you when you were 5, and I'm like, how did you know that? I don't think I look like that anymore, and how'd you know that wasn't my daughter? Like, that's, and that's because they're improving their algorithms, they're using pictures of individuals who are aged, understanding how individuals' faces change,
Right.
etc.
And sometimes you'll hear things in the news about how, like this product doesn't see black folks, or this people that understand brown skin, or whatever. It's very rarely evil. You have to remember that in all software, it's almost always incompetence.
Yeah.
It's that people don't know what the hell they're doing. But
Objects.
once you give a data set to it, the computer can be taught to understand everybody, all lighting conditions, and things like that.
Yeah, exactly.
Cool.
Other questions, yeah?
Will these PowerPoints be on the website?
Yes, yeah, so we're gonna put,
Everything.
can we link the video once it's live?
Absolutely.
Cool.
Yeah, we'll link to everything.
Yeah. Other questions, yes?
Yes, ma'am.
I don't know if this is,
Don't ever apologize, and don't ever preface a good question.
Yeah, just ask it.
Just ask a question.
how, along those lines, how do you like manage like the bias of like a person who's creating a program, or like who's doing, if it's like, it doesn't recognize black people, it doesn't recognize whatever, how does like a program that's made for everyone
That's a great question.
representative.
So how can it do that
Let me
if the
put-
person who's creating it is
Let me put a little
part of it?
bit of a advertisement. This is my podcast, and it's called Hansel Minutes. And on this show, I've had people on the show, and if we look for bias, this young woman here did a show, this is show 607, called Removing Bias from AI. She's a scientist in the space of artificial intelligence, and she talks about not just bias, where like I accidentally made a thing that doesn't see people, but also implicit cultural bias, where like one country might think something about people, and you might Google for girl and see one thing in Egypt that you see in Germany, and you see a different thing in Canada. And it is the simple recognition of that stuff. Once you've shined a light on it, you go, wow, that's not what we intended. But what is intention? That's specification. You've got to spec it out ahead of time. You don't want to go and put a thing out and go, oops, it's a thing. Microsoft put out a thing called Tay, T-A-Y. It was an AI bot, and it was supposed to have chats with you. And they put it out in Japan, and it had these really sweet, gentle conversations with the Japanese. Apparently, Japanese people are kind when they chat, for the most part. Then they brought it here. And within about 7 hours, it turned into this just mean, horrible cesspool because people were poisoning the data. Some folks on like 4chan found it, and they taught the AI to be not just racist, but just like evil. They basically grew like baby Hitler. And the reason that happened is that they never not specified, don't make it Hitler. They never ever called that out. They just said, well, it'll learn. Right? In Terminator, if they had specified that we won't allow it to destroy the world, it probably wouldn't have destroyed the world. But there was no spec. Open-ended specifications cause bugs. So knowing what your intent is and gating it.
And how do you do that as an individual, right? And especially as like a junior individual, and especially if you're representing a diverse population, right? And you feel like now it's all on my shoulders to always be the one who says, hey, what about those of us with boobs? Right? That feels awkward. You were gone.
Yeah, I missed something.
Right? It is important to speak up. It's important to find community, find people who are in like more of a privileged situation and have them speak up, to have diverse teams. We talk about it a lot at Microsoft, but when we are looking for inclusive teams, it is because we are looking for people with different backgrounds, and we have to be deliberate about what we're building.
This woman here, you can go and find this, you can search for AI. She's a doctor, and she actually worked with Microsoft to create guidelines for interaction with AI. So it's like you go and design, like, what is a interaction supposed to look like? They have these guidelines. Let me find the example here real quick.
So there are specifications and things.
There you go. So make it clear what the system can do. The opposite of that, what can it do and how well does it do it? If you go and say, that is a dog, period, I'm a computer and that's a dog, right, and it's your mom, then you need to have an AI that can say, hey, a little gentle feedback, I need to train you that that's in fact not the dog, it's my mom. And then match relevant social norms, mitigate biases, and then when you're wrong, how hard is it? Like, you know the thing that sucks about Google Maps is when it's wrong, it's freaking nuts. Like the teriyaki place is across the freeway, and there's no way to fix it, right? And it's like, oh, fill out this form and upload your driver's license and I will move the teriyaki place over here, right? But if you could just shake the thing and move the pin, that'd be awesome. But then you could poison it. And one business could ruin another business's experience. None of those are coding problems, those are specification problems.
And I just want to call back to something we were talking about earlier in terms of human skills. As developers, we talk about people with egos. When we're doing things that are so kind of precious, like machine learning, that are going to affect humans, we need to check our own implicit biases, and we need to be okay with someone saying, hey, I don't think you thought about people with boobs, right? And not take offense to that, and realize that there's kind of like a bigger picture here.
Yeah, one of my biases that I notice is young people. The older I get, the more I become like old man who shakes fist at cloud. And I'm like, you're 22, you can't tell me shit, but you have 22 years of experience being you, so you probably do have some interesting stuff to say. And I have to keep, check that. So when a 22-year-old at school, or work rather, tells me something, I'm like, but I have to check myself and go, okay, I will hear your idea, then I will tell you that you don't know what you're talking about.
So I want to give us just a few minutes and then we can continue to ask questions. But I would really, really appreciate it, and I have a present for you if you do. But if you can just go to aka.ms/college tour. Okay? Everyone go to this on any computer or cell phone.
And if you fill out that survey for us, we will give you free Azure.
Ooh, So, and I will show you how to sign up for that free Azure money. So aka.ms/college tour. If you're on a phone, there's going to be a readme and then you'll have to say like view more. But just scroll down and it says survey then lunch. Go ahead and just click on survey. So aka.ms/college tour, scroll down and click on survey.
Or you can hit Control F and search for survey,
Yep.
fine.
And there's two of them, they're both pointing to the same one, so you can click either, but survey. And it's a very short, anonymous survey. Please give us feedback. We didn't get a chance to do all of the different types of sessions. So there's one that like rates each session and like it's like IoT, and if we didn't do it, just push NA. But please give us feedback. And then I'm gonna be walking around giving you keys.
Where did they go for that?
And yeah, so Google Azure for Students. We still have 20 minutes, so I'm not too worried about that.
So then you can go with the key that we're going to give you and go to activate Google, go ahead and Google for Azure for Students.
I just need to give a little bit more detail on that because there's a really easy
Yeah,
way to
she'll
get it.
walk you through it. It'll give you a bunch of tools and it won't require a credit card.
Live after school and Q&A, that's what we're gonna do after.
And then
So
we'll
we did
hang
it
out and
during
talk to
lunch.
you.
Okay.
Yeah, the life after school and Q&A we did during lunch.
Yeah. But if you got more questions, I'm sure we can talk.
Yes. Say that again?
So go to the README.
And just scroll down, yeah. Okay.
Battery's at 25.
No problem.
And if you hit, yes, there you go.
And this is where you'll find all of the resources from today. If they're not up there yet, they will be.